Let's take a look in more detail at the equivalence between mass and energy that we presented in the previous video. What do we mean by a photon forming part of a body? We will actually need a minimum of two for this to be possible. Let's consider a ball at rest, with a reflective internal surface. We can fill this ball up with photons. The ball will only remain at rest if the total momentum of these photons is zero. Otherwise, there would be a net push on the ball due to the collisions of these photons with it. We consider just two photons moving horizontally in opposite directions for simplicity. We are interested in looking at this ball from the point of view of a moving train that approaches the ball, as you can see here. According to the train approaching the ball with velocity v, the photon on the left will have a momentum reduced by ev, and the one on the right increased by an amount ev as well. This is seen in the different wavelengths shown in the figure. This is what we'll call a ball with photons in it moving at constant velocity v. This is our definition of it. If we want to bring such a ball from rest to this configuration in a given time t, that is, supplying an acceleration a equal to v over t, we'll need to change the momentum of each photon by ev in that time, which will require a force F equal to ev over t, which is equal to the energy times the acceleration. We see that the larger the energy of the photons, the bigger the force required to supply this acceleration. That is exactly the role of mass in Newtonian physics. So the energy of the photons works as an additional mass for the ball.